So we have two equations, one for sine, one for cosine. They're similar. It's just one's trig function for sine, one's for cosine. So those are the two that we're going to write equations for today, and then tomorrow we'll do the tangent ones. All right, so different formulas to find the A, the B, the C, and the D values in each of these. Amplitude, remember, absolute value A, the B value. We use the period 2 pi divided by B because it has the B in it. Phase shift, we use that to find the C value because it's the formula that has C in it. And then the vertical shift has the D, right? So you can see where A, B, C, and D come from to plug it into the formula. All right, so let's go ahead and we're going to write a sine function for each of these first. So they give us the amplitude, they give us the period, the vertical shift. And so we're just going to plug that into our formula. So since the amplitude is 15, you can use positive 15 or negative 15 for A. It doesn't matter because we're just writing an equation. And if you use the negative 15, the absolute value of negative 15 is still positive 15, tells us our amplitude. All right, so again, you could use the positive or the negative. Now, if they said that A equals negative 15, then it has to be negative 15. But since the amplitude is what they're giving you, we use either 15 or negative 15. All right, so this is 15 times sine. Then we're going to do parentheses. And then usually what I do is I look for my vertical shift to put that in. That's the D value. So down 10, so that's going to be minus 10. And so then the next thing we always want to do is once you have your A and your D values in there and you know which trig function you're writing, you want to find B. All right, so B is the number in front of the X. And so you get that by using the period formula. So period, okay, is equal to 2 pi divided by B. That's our formula that has B in it. Now we want to solve this for B. Okay, now we already know what the period is. They tell us we can put 4 pi right here. But one thing that we can do is if we want to get B by itself, what could we do? How can we get B by itself? Anybody? Solve for B? Well, we could multiply by B. Then we could divide by the period. So we get B equals 2 pi divided by the period. Let's put P for period. So if I want to find the B value, all I have to do is now do 2 pi divided by the period. Well, they give us the period is 4 pi. So 2 pi divided by 4 pi simplifies to a half. So B is a half. So I can plug that in 1/2 x. There's no phase shift, so there's no C value. It's just 0. So that's the equation. So in our formula now, all right, we have phase shift equals C over B. Anytime you're trying to find right here. Anytime period equals 2 pi over B, anytime we're trying to find B, just switch these two. Right? So the B will go over here, the period will go here. We already saw why it works. And so it's going to work every time. So B is equal to 2 pi divided by the period. All right, so next one. So again, we're doing a sine function. So amplitude is 1, so we could use either positive 1 or negative 1. Doesn't matter. All right, in parentheses, we're going up 2, so plus 2 at the end. All right, so now we want to find the B value, so we use the period to do that. All right, so our period is equal to 2 pi divided by B, which we could rewrite it as B equals 2 pi divided by the period. All right, so then we have 2 pi divided by the period, which is pi over 3. So we have a complex fraction. So what would 2 pi divided by pi over 3 simplify to? What is it? No. 2 pi divided by pi over 3. What does that simplify to? No, not pi over 3. What is it? 6. Yeah. 2 pi times 3 over pi. 6. B is 6. So it's 6x. All right, so now we want to find C. There is a C value because there's a phase shift. So we can use the formula. The phase shift is equal to C over B. Well, we have a phase shift of pi over 4 equals C divided by the B value, and B we already know is 6. So we have pi over 4 equals C over 6. How can we solve for C? Multiply by 6. So we have 6 pi over 4. That simplifies to 3 pi over 2. So C equals 3 pi over 2. All right, so now we can put the C value in. Since it says it's going right, that's in the positive direction, we change the sign and put a minus and 3 pi over 2. All right, so now let's do a cosine function. So amplitude is 2, period 2 pi, phase shift to the right, pi over 2. All right, so y equals 2 times cosine. We'll put parentheses. There's no vertical shift, so d is 0. So now we're going to find b. So we use the formula period equals 2 pi divided by b, which is b equals 2 pi divided by the period. So that's 2 pi divided by 2 pi, which is 1. All right, so our b value is 1. So it's 1x, or just x. Now we have a phase shift to the right. So that's going to go in the positive direction, so we put a minus sign. So now we can use our formula. The phase shift is equal to C divided by B. So our phase shift is pi over 2 equals C over B is 1. And C over 1 is C, so C equals pi over 2. So pi over 2. All right, so see if you can do B. We have an amplitude of 0.5, period pi over 4, vertical shift down 2, phase shift left pi. so this is the equation. Should have. All right, so go ahead and turn it over. All right, so now they give us equation or graphs, and then we have to write the equation. All right, so the first thing you want to do is find the midline. So the midline is going to be the middle between the highest and lowest points, because you want to see if there's a vertical shift on this. All right, so the highest on number 3 we can see is +2, and the lowest is -2. So our midline is right on the x-axis. All right, so now we know that the d value is 0 because there's no vertical shift. All right, the next thing we want to do is check to see where the graph crosses. Does it cross high on the y-axis, or does it cross at the midline? Okay. Well, here it's crossing at the midline, okay, right here, and the y-axis, that means it's a sine graph. Right, so we know it has to be a sine graph, not a cosine. All right, so sine graphs start at the midline. They typically go up, down, and end at the midline. The a value is the highest point from the midline, the distance, right? So we can see this distance right here. That's a, which is 2. All right, and so we have our amplitude, it's 2. All right, we want to know what 1 period is. So if we trace out 1 cycle of the graph, this right here is 1 period. That's 1 cycle. And we can see that it would end at 4 pi. So 1 period is a length of 4 pi. Since the graph is crossing at the y-axis, that means there's no phase shift. C is 0. There's no vertical shift, so D is 0. So all we need is the a and the b value, and we already know that it's a sine function. All right, so now we can write the equation. Y equals 2 times sine. So we want to find b, and so we use b equals 2 pi divided by the period. So b equals 2 pi divided by 4 pi, which is 1/2. So 1/2 x. All right, so number 4, our highest is 6, and our lowest is 0. So that means there's a phase shift. And so the halfway point would be 3. So here's our midline at 3. All right, so our graph again crosses the y-axis and the midline. So that means that it's a sine graph. Okay. Our a value, the distance from our midline to the highest point, that's 3 units. So a is 3. We trace out 1 cycle of the sine graph. Here's where it ends. So again, you can see it ends at 4 pi, so our period is 4 pi. We do have a d value, so it's shifted up 3 units. All right, so we just plug in the numbers. All right, so we can see a is equal to 3. And it's a sine graph, so 3 times sine plus 3 is our d value. One cycle of the graph, right here, that's where it ends. So the period is 4 pi. So b equals 2 pi divided by 4 pi again, which is 1/2. So 1/2 x. Yeah, because it's starting on the y-axis. So it starts at the y-axis and the midline. So there's no phase shift. All right, number 5. Our highest is 2. Our highest is 2. Our lowest is -2. So the halfway point is the y-axis at 0. All right, now because the graph crosses through the midline and the y-axis, okay, right there, we don't have to put a phase shift. We don't have to write this for phase shift. Okay, we can just write it as a sine graph because it crosses the midline and the y-axis in the same spot. So we can just use the sine graph. It starts here, goes up, hits here at the midline, comes down, and then it would end over here. So that's one cycle of the graph. If you can write an equation without a phase shift, it just makes it easier. Right? You don't have to deal with the c value. We'll do one with it, but if you can do it without, okay, so this is just so you can see that's one cycle. So what would this length be? What would the period's length be? Well, we know that this is the halfway point of the cycle, right? And the halfway point has a length of 2 pi. So the other half would have to be another 2 pi, and so 2 pi plus 2 pi would be 4 pi. So we know it would end right here at 4. All right, the a value is 2. A is 2. All right, so y equals 2 times sine 1/2 x. All right, number 6. Our highest is 2. Our lowest is -2. It's starting high on the y-axis, so that means that this is a cosine graph. All right, we can see the midline again is the x-axis. No vertical shift. Our a value again is 2. One complete cycle. It starts high, ends high. So this would be 4 pi again. Because the halfway point we can see is 2 pi. This is the halfway. So the other half has to be another 2 pi. All right, so our equation y equals, this is 2 times cosine. One half x. All right, 7. Our highest is 1.5. Our lowest is -1.5. So that means our midline is right at 0 again. All right, so our a value is going to be -1.5. It's a reflected sine graph. Starts at 0 and ends at pi over 2. So it looks like one cycle is pi over 2. All right, so our equation y equals -1.5 times sine. So we need b. So b equals 2 pi divided by the period, pi over 2. Okay. And so that would be 4. All right, last one. So this one we are going to do a phase shift on it. All right, so our midline again is at 0. These are going up by halves, so our a value is 1. and it's a sine graph. All right, so we have to find b, and to find b, you need to know the length of one period. And so what's the horizontal length from here to here? What would that one period length be? What is it? 2 pi, yeah. This is negative 3 pi over 2 here, and this is positive pi over 2. So the distance from here to here is 3 pi over 2 units, plus another pi over 2. Okay? So 3 pi over 2 plus 1 pi over 2 is 4 pi over 2, which is 2 pi. So from here to here is 4 pi. 2 pi, sorry. All right, so b equals 2 pi divided by the period, 2 pi, which is 1. So 1x. It's being shifted to the left in the negative direction, so we need to put a plus. All right, and it's being shifted to the left 3 pi over 2 units. And you can see that this works. 2 pi divided by 1 is 2 pi. Total length is 2 pi. C divided by B, 3 pi over 2 divided by 1 is 3 pi over 2, shifted to the left. So it starts at negative 3 pi over 2. All right, and that's it.